mixtures of gases. According to kinetic molecular theory, if you have a mixture of gases, because the particles don't interact with each other, and because there's so much space that's empty between them, they act like they're the only gas in the sample, in the mixture. They are completely independent of each other. But each of those gases in the mixture is going to exert its own pressure on the container. And those pressures are called partial pressures, because they're only part of the total pressure. The partial pressure of any component is that component's fractional composition times the total pressure of the mixture. So if you have two gases and half is neon and half is helium, half the pressure will be from neon and half will be from helium. Let's think about air. Air is 78% nitrogen, 21% oxygen, 0.9% argon, and 0.04% carbon dioxide. There's some other little trace gases that are not worth talking about. Well, the nitrogen molecules in the air exert 78% of the total pressure because they're 78% of the molecules. And that pressure is independent of the other gases. The nitrogens don't interact with the oxygens. The oxygen molecules exert their own pressure, which corresponds to their percentage of the number of molecules. So the air is 21% oxygen. 21% of the total pressure is from the oxygen. Here we have a gas mixture, 80% helium, 20% neon. The total pressure in this box is 1 atmosphere. And so we can figure out what the partial pressures of each of these are. If it's 80% helium, then 80% of the total is the pressure that helium has. So you can do it just kind of thinking if you're comfortable with percentages and stuff, or we can look at it this way. The fractional composition is the percent composition divided by 100. So if it's 80% helium divided by 100 equals 0.8. That's the fractional composition of helium. The partial pressure of helium equals the fractional composition times the total pressure. So that's 0.8 atmospheres. What's the fractional composition for neon? 20% divided by 100. 0.2. So the partial pressure for neon is going to be 0.2 times the total pressure, which equals 0.2 atmospheres. If you add the partial pressures together, they give you the total pressure. So a gas mixture is 64% methane and 36% ethane. If the total pressure is 1.44 atmospheres, what are the partial pressures of each component? We need to take these percentages and convert them to fractions. So 64% is 0.64, and 36% is 0.36. So the partial pressure of methane is going to be equal to its fractional composition times the total pressure. 0.64 times 1.44 atmospheres. 0.64 times 1.44. 0.92. And the pressure from the ethane is going to be 0.36 times 1.44 atmospheres. These are partial pressures. So that equals 0.54 atmospheres. No, 0.52. I didn't think that was right. And what happens when we add these two numbers together? We get the same total, 1.44. So that's the idea of partial pressures. There's a law for that, Dalton's law of partial pressures. If you take each of the pressures, partial pressures for the gases in a mixture and add them together, that equals the total pressure of the gas. If you've got a gas that's hydrogen and water vapor, should sound familiar to the people who did lab yesterday. Here's the total pressure, 745 torr. The vapor pressure, the water, has a partial pressure of 24 torr. What's the partial pressure of the hydrogen? P total equals the pressure of the water plus the pressure of the hydrogen. You just subtract. So 745 torr equals 745 equals 24 plus what we're looking for. So the pressure of the hydrogen is equal to 745 minus 24, which I think is 731. No, 721. That's why you use your calculator. Any questions?